Assalamualaikum and hello everyone. Today I'm going to present my thesis, which is the effect of carbon black in enhancing tensile properties of ultra-high fluid polyethylene. This is the outline of my presentation today. Okay, now let's proceed with the introduction. Okay, what is polyethylene? Polyethylene is a thermoplastic made from ethylene gas. It is the most widely used plastic in the world. There are many types of polyethylene, which is low density polyethylene, LDPE. It is a flexible and lightweight plastic, for example, plastic bag and cable insulation. Next, linear low density polyethylene, LLDPE, which is more flexible and impact resistant than LDPE. It is used for agricultural film and plastic wrap. Besides, we have high density polyethylene, HDPE, which is a strong, durable and chemical resistant, for example, bottle and storage tank. And last but not least is ultra-high fluid polyethylene, which is the extremely tough, wear resistant and low friction. We have used ultra-high fluid polyethylene in daily life, such as cutting board, gear and ropes. In my thesis, there's a full problem statement, which is processing and molding problem of ultra-high fluid polyethylene, lack of research related to carbon black with ultra-high fluid polyethylene, and limited research on solid-state composition molding. The objective of my study are to prepare the carbon black with ultra-high fluid or polyethylene composite via solid-state compression molding, to evaluate tensile properties of carbon black with ultra-high fluid polyethylene composite via tensile test, and to identify the functional group in carbon black with ultra-high fluid polyethylene composite via FTIR and morphology via digital optical microscope. Okay, now let's proceed with the morphology. First of all, 3 grams of carbon black with ultra-high fluid polyethylene composite powder was weighed with different carbon black loading ratio and then mixed by using roller mixer at 50 rpm about 50 minutes. And the hot press machine was preheated to 200 degrees Celsius. After that, the powder was pressed for 20 minutes under 5 MPa pressure, and lastly, the composite was produced. I did the surface morphology using digital optical microscope and tensile test by using instrument machine and characterization using FTIR. Now let's proceed with the result and discussion. The proof spectra is carbon black and the grain spectra is ultra-high fluid polyethylene. For ultra-high fluid polyethylene, at 2800 P is for CH stretching, 1490 is CH branding, and 730 is for CH rocking. For carbon black, at 3600 until 3400 is hydroxy group, 2100 is CH stretching, 2300 until 3100 is C double C stretching, and 1700 until 1350 is carboxyl and carbonyl. This is a graph for carbon black with ultra-high fluid polyethylene composite. As you can see in this figure, both peak in carbon black and ultra-high fluid polyethylene exist in the composite, so it shows the same peak as stated in the last slide. Okay, for tensile test, the tensile strength drops sharply in increasing failure loading in ultra-high fluid polyethylene foam composite. Why this happened? This is due to the no chemical bonding between ultra-high fluid polyethylene and carbon black, because ultra-high fluid polyethylene was a saturated bond which did not allow any chemical reaction. For tensile properties, the elongation area and the Young modulus shows the opposite trend. This is due to the agglomeration and poor filler dispersion. Now, let's talk about the morphology. As you can see, the A figure is ultra-high fluid polyethylene without filler, B is 1 php of carbon black with ultra-high fluid polyethylene, and C is 5 php of carbon black with ultra-high fluid polyethylene, and D is 10 php of carbon black with ultra-high fluid polyethylene. Lastly, the conclusion. Carbon black with ultra-high fluid polyethylene composite was successfully prepared using solid-state compression molding. Tensile testing shows the carbon black influenced the mechanical properties of the composite. FTIR analysis detected the significant new functional group indicating minimal chemical interaction. Digital optical microscope confirm the dispersion of carbon black particles within the ultra-high microwave polyethylene matrix, and the study shows that the solid-state compression molding method are not suitable for this research. My recommendation for my study is using internal mixer because it provides better dispersion and can control the processing process. Thank you for watching.